All right, hello? Yes. Okie dokie. All right. Where are we? Let me snap this in place. Okay. And I got everything in. And okay, folks, just give me 1 second. I'm setting a couple things up here. Where am I? Yep. Okay. Yes. Alrighty. Okay, are we ready for this? I guess I'm never ready for this, by the way, but I just fake it until I make it. All right, so hello, welcome everyone. My name is Jose Luis. For those of you who may not know me, and this is Parametric Camp. We record live streams where we talk about computational design. We write code, we do nerdy things, we focus on design and creativity, and we typically record tutorials live that we'll then edit and turn into videos that people can follow, playlist, small courses, etc., etc. If you want to learn more about what we do or you want to stay up to date with what we do, we are in social media. We're particularly active on Instagram. We have a Discord server that I really recommend you join because it's our way to have a conversation throughout the week, to get to know each other better. People post technical questions. We announce when we go live. People give me suggestions for topics to make videos on. It's a great way to connect. It's my favorite way to connect as of these days. All right. So the link to the Discord server is in the description of this video. And we also have a Google Calendar that you can subscribe to if you want to get notifications of when do we go live, such as today. The link is also in the description of this video. Whew. I think I should just pre-record this and play a video so that I can like drink my coffee while I welcome new people to the channel. So I'm gonna grab a sip in the meantime. How's everyone doing? Arastu, hello. Drilon, very good to see you. How are we doing? Okie dokie. So what are we doing today? Oh, well, before, yes. So I was at the University of Pennsylvania this week. I was hanging out and walking around. For those of you who may, I used to teach there in this program called the MSDRAS, basically a Master's in Design Science in Robotics and Autonomous Systems. The University of Pennsylvania is beautiful, has a beautiful campus. It's really nice to be there. But the program is also quite interesting because it's about fabrication, robotics, autonomous systems, agent systems, some machine learning, I think. And students, it's a one-year program. It's very nerdy. And students focus on doing projects that somehow have to do with architectural construction. This year, the topic was ceramic and the topic was facades. So, and I was there and the work was really good. Kudos to all the students who presented their work there. Kudos to Robert Stewart Smith, who is the program director. Kudos to Billy Faircloth, Nathan King, Jeffrey Anderson, who are the main faculty of the second semester of the program. There's also faculty in the first semester of the program. It's a very interesting program. So these are actually the faculty. So this is Rob, Billy, Nathan, and then Shelby and Laura. We were all there for the review of it was really nice, a very good program. Congratulations to everyone for finishing and for graduating. It was very nice. I love seeing what creative people do when they have time to explore and research, and they have good professors who encourage them to, ask interesting questions, prototype them, etc. So anyway, that was fun. It was Monday, and now I'm here again with all of you. So what are we doing today? That is a good question. What are we doing today? I guess we are continuing with where we left it last week, which is we are building this brain plugin. All right. Sorry, I have some coffee in the stove. I don't want it. So we are building this brain plugin, and I believe last week what we did, we're building collectively this plugin for. Oh, I haven't published the videos. Oh boy, I forgot about this. Totally. Oh boy, I really need help with this. I did upload the videos. I have them ready to. I just didn't press the button to make them public. Okay. All right. So I guess I'll do that next week. So last week, what we did was we are building this plugin called Brain. It's for machine learning. It's basically to access machine learning APIs like OpenAI, IBM Watson, etc., etc. And what I would like to do, and what we did last week is that we plan the thing. We have a set of goals. We studied the GitHub repository. We studied the C# project, and then I created. Did I create anything? I did not create. No, we just set it up. And then what I did was I sketched the first. I sketched the first. I did sketch the first component, which was an HTTP post request. Okay. And I did prototype it real quick because I wanted to try a few things out, and I actually came up with a couple of interesting patterns that I may want to record this time. So I think what we're going to do in this live stream is that the prototyping that we did last time, we're going to turn it into videos. And then if we have any time, any additional time, I would like to further prototype a couple things so that we have that code ready for recording videos next week. I think that's what we're going to do today. Any questions, comments, concerns, wishes? I've gotten a couple requests recently on Discord that I thought were very interesting. So I wonder if maybe next live stream we take a break from the plugin. Oh, the coffee. Sorry. I'll be right back. The coffee. Not this one, this one here. There you go. Can you see the steamy? Nice. So you're gonna get me high on coffee, on caffeine again. So I was saying, yeah. So what we're gonna do today is we're going to record the videos for the previous, and let me pull up my notes here. So I have notes stream. What do I have? Notes, yeah. Okay. And the brain plugin, philosophy goals. I think we had the video somewhere. Brain plugin, Grasshopper, yes. So first do a blocking, prototype it real quick. Yes, so row post component. So this is what we did last time. We have these 3 videos. I haven't published them. Then we're going to prototype a post component. I prototyped it last week, so I have the code that I want to go over. And the first thing that we're going to do is we're going to prototype like the simple version. So a version that just executes the request, and then it takes some time to execute, and then it blocks that, etc., etc. And then I'm going to explain that the problem is that whenever we do this, the entire Grasshopper, everything freezes out because requests go through the internet, they take time to resolve, etc., etc. So we're going to upgrade to an asynchronous version. The asynchronous version is not going to block the Grasshopper, but then once we implement that, we're going to see how Speckle by default gives us this percentage kind of progress bar, which I don't like. So I'm going to switch and modify Speckle to accept a string message as opposed to a double message. And we're going to use that as a way to learn how to modify people's code. I don't know. And then the next thing will be just to make the same thing, but with a get component. I want to maybe at some point do icons. No, is icons interesting? I don't know if it's interesting. Anyway, so, all right, so let's see where we were. Where do we have the code? Where do we have the code, folks? We have the code. Where do I have the code? Code parameter. Ah, in parametric camp. Okay, parametric camp, brain plugging. Okay, so source, and we have the speckle. Okay. Yeah, and we have all of this. Okay, I'm going to make myself a copy of this and I'm going to put it on my desktop because I'm going to revert all the changes that I did last time. So if I go here and you see git status, oh, I committed the changes. Oh boy. Let's go to the repo. Oh, that's not good. Well, I mean, I guess it doesn't really matter. So here, brain plugin, Grasshopper. The last thing that I uploaded was video roadmap. No. Prototype at asynchronous post with custom string progress. So I did implement that. Okay. So I guess I'm gonna have to manually undo it. Okay. All right, so then let me undo all the changes here. So I'm going to open, what do I have here for tests? Here, the solution. So I don't want any of this. Yes, I don't want any of this. SPI, asynchronous speckle. I don't want any of this either. Nope. And then, so that's going to be the one that I have online. But I'm going to want to use my cheat sheet. So I'm going to open the one that I just copied. And I'm going to keep it here on the side. And this is the one with everything. With the utility components. And yeah. And so I guess I'm going to start one at a time. And then I will add an icon here. Just watch the Boston Dynamics video of them integrating their dog spot to React Native voice command and give him a... So I have high expectation of this Grasshopper design. Oh boy, I feel you are leading yourself to disappointment with us, novice artisan. There's a non-speckle async version. You have a pull request, Victor? What? I have not seen that. Parametric. Really? Where are we? How did I not see this? Build workflow, open 3 days, add a GitHub action to automate when release plugin when version number is changed in C#. Oh, added a post build script to load plugin when building locally. Added launch settings to run Grasshopper command when building locally. Why am I not getting notifications for this? I did not get any single notification. Post async without speckle. Huh, okay. Without speckle. So you're basically... Okay, I didn't see that. Why am I not getting notifications? I wasn't watching my own plugin. This is not good. Am I not watching this either? No, I am not. I am not watching tutorial files. This. Well, okay. I am watching this one. This one I'm not watching. Weird. And there's a pull request here. Fix my T typo in program. A mighty clicker. All right, so I guess I'm going to accept this one. And then this one doesn't have. Yeah, I'm sorry. I had not seen that. I actually hadn't picked up that I was not. I hadn't picked up that I was not getting notifications. And who's forking this? Oh, the Kauskish and Lynn. All right, Victor. Well, I guess I'm going to start my own thing as well. Okay, thanks for that, Victor. I had not seen that. So how are we going to... So the thing is, Victor, and this is a challenge for you. Since you're here, I didn't... Okay, we have speckle async. So what I like about using speckle is that we get the... What I like about speckle is that we do get the message on the bottom. We get the tiny drop down in the bottom. So I wonder if... Where does it display the message? This dot message? Ah, all right. I see. Okay, I like this then. All right, so maybe we don't use speckle. Maybe we just use this, you know? And the way you're doing that is that expire solution, delegate, recompute, task, run, try, request get string, and then the callback, and then the callback is invoke on ion expire solution, true, and it's a method expire solution delegate, true. And where did you get this from? Is this also from speckle? Is this basically what speckle is doing under the hood? Magnin forum. Okay. I I think the lag is not a lot today, which is great. Okay, interesting. All right, so let's record. Okay, so let's stick to the plan. So what we're going to do is we are going to do the block inversion, and then I'm going to take a look at your files, Victor. Where are we? Should we just merge right now? Should we approve them? So you're basically doing changes here, request components. Yeah, so you're basically just changing the component async version. Okay. All right, so let me then, what are we going to do? Git status, I have modified git reset, git status, git check. Okay, so now everything is back here. So then what I'm going to do is I'm going to approve the change. Oh, but I would like to keep the asynchronous version too, with async no speckle. So I'm going to merge the request. Yes, we're going to merge. Okay, and then it's closed, and then we're going to pull. And now we got here the version with the callback. Which is in its own file. This is great. I love it. Okay, so now we are going to, I'm gonna turn off Dropbox. Is gonna be, we're going to take this and I'm going to move it somewhere to my desktop. We're going to undo everything. Yeah, I do Git in a very manual way, if you know what I mean, sometimes. And then we have the plugin itself, and then this one. Okay, so I have a copy of that. And now, yes, so I've deleted everything, but this version is still on Git. Beautiful. Thanks for that, Victor. I think we're going to incorporate that in our, and I wonder if there's a way we can abstract that method. Well, we'll see when we learn. When I take a look at the code, maybe we can abstract that into an asynchronous request Grasshopper component of some kind. Okay. All right, so that's there. I'm gonna move that here. I'm gonna move this here. And then if for the video, we want to start here. And the first thing that we're gonna do is we're gonna do a block inversion. So let me actually pull this up. And I have here on the side the version that I want to do. Okay. Which is going to be start with the post request, the simple post request. And actually, so how is the video going to look like? I think for that one, we can actually refer to the, I have a video somewhere, asynchronous components. Perhaps one of the videos where we were doing DALI. Perhaps one of these could work. How to use DALI in Grasshopper, fun with... Okay, so maybe I can refer to that. Or ChatGPT web app. Yeah, I guess we could do one of those. And I could talk about this. And I wonder where is the code for this one? Okay. Okay, perhaps I can refer to this one. Okay, so the video is going to be an introduction. The video is going to be an introduction. The video is going to be an introduction, which I will record later. And then it's going to be, okay, first things, what do? We're going to do an HTTP post request, which basically means, what does that mean? This guy with this thief. What is a good image for an HTTP post request? I don't know. I don't know. Yeah, I don't see anything. I'm kind of getting a headache right now. Ugh, this is not going to be good. This is a terrible example. HTTP. Okay. Post request body. Yeah, nope. HTTP verbs. I guess. Oh, this is terrible. Yeah, I'm not gonna use any of this. Maybe we can go to the developer. OpenAI, where can I go to the developers? Developers, OpenAI platform. Okay. So the API reference, completions. Okay. All right, so I'm going to start by talking about what a post request is, how we've done it here, etc., etc. Okay. Okay. All right. Let's do this. Let me concentrate. Let me focus. Okay, let's get started. I am all over the place today. It's not going to be a very efficient live stream. Oh. Okay. Let's start by the beginning. So what I would like to do is I would like to create a component that is going to be a general request to any possible API that we might find out there in the wild. So the goal with this component is that if at some point in the future people don't have the OpenAI component, the IBM Watson or something changes, they have the access to composing a custom request with their own parameters, their own body, etc., so that they can access any API that we may not have developed a specific component for. So in HTTP world, you will see that, for example, here's the API reference for OpenAI. You can see that in the most general terms, when you want to ping the OpenAI API, when you want to basically get a prediction from some AI model that lives inside of OpenAI, what they tell you is that you just need to do a post request to this URL that you have here. And then they give you some documentation about what that request has to look like. The idea is that post requests are basically HTTP requests, very similar to the one that you do when in your browser you type youtube.parametriccamp and then you get information. This one is a GET request because you're basically saying, give me whatever you got. But post requests are a more, let's say, complex version of that, where you also go to an URL, in this case what we call the endpoint, but on top of that you also send some information with the request, like for example which model you want to use, what is the prompt that you want to take, the temperature, the maximum tokens, etc., and the server uses that information to customize the response that it gives you back. So we already, actually, in this channel, we already did a bunch of examples of post requests and how do they look like in Python, JavaScript, C#, and even an implementation that we did for Grasshopper. So we actually wrote a C# script for Grasshopper that does generic HTTP post requests. So if you want to learn more about that, or if you want to see the example of DALI, a link to this video will probably pop up somewhere in the corner here, right? But what we're going to do now is we're basically going to create a component that can do any post request to any endpoint. This is going to be the goal of this video, all right? Okay, so how are we going to do that? Well, the first thing that I would like to do is to be very ordered and very categorical about making sure that everything is in the right place. So to make sure that my OCD is happy, I'm going to create a new folder and I'm going to call this utility components or utility comps. And inside of this folder, I'm going to add a new item that is going to be a grasshopper, an empty grasshopper component for right now. And the name that I'm going to give the component is going to be HTTP post request component. All right, like that big, all right? And as I do that, I do already get the HTTP post request. I already get a template for the component. We've seen this in previous videos. And because I created a folder, my namespace is also the brain plugin.utility component, which is kind of nice. All right. So let me just make sure that I fill in a bunch of things. So the full name, I like the full name, post, and this is going to be create a generic post HTTP post request, and this is going to be synchronous, and I will explain what that means in the future. All right, and then the category is going to be the brain plugin, and the subcategory is going to be utilities, for example. All right, beautiful. Okay, so then we're going to customize the inputs. What are we going to take as inputs for this general HTTP request? Well, there's a bunch of things that we need to take. So first of all, we need to take the URL, or what is typically referred to as the endpoint. All right, so that is the HTTP dot blah blah blah. We also need to take, for example, we're going to need to take the body of the request. So that is the information that we're going to be sending with this request. We will need to take, for example, also the content type. So it turns out that with post requests, you need to add to the request a small header that says whether if the body that you're sending is a JSON file, is a text file, is an MP3 file, is an audio file, a video file. There's a lot of different types of requests, of information that you can bundle in your request, okay? So we will also, in the future, at some point, we will use custom headers. Custom headers are very useful for sending additional metadata with your HTTP, but maybe we do this later in time. We're not going to implement that for today for whatever for reasons that I will explain. And we will want some kind of authentication. So depending on which API you use, you typically have to provide some kind of authentication. Maybe the API is free, but if it's not, you need to send your bearer token, some API key, some form of authentication so that the server knows who you are, and then whether if you're authorized or not, and who to bill if it's a paid service, right? And last but not least, we probably want to implement some kind of timeout. What that means is because requests over the internet take time to execute, they're not immediate. They take time due to network traffic. They take time because the server might be busy fulfilling other requests. So typically what we do is we said, yeah, you know what? If you didn't give me a response after 5 seconds, I'm just gonna cancel the request. I'm not interested. Like, I just don't want to wait forever. Okay. So we're going to use this as our initial entry points, as the first few things that we're going to add to the component. So how are we going to do that? Well, and whether, this is very important, and whether if the plugin or the component is active or not. So whether if this is actually performing requests or not. So we're going to add these inputs. Actually, give me 1 second. I'm going to do this offline. Okay, so I'm just going to input this here. And here you go. So I have created a Boolean parameter for whether if we're sending or not sending information. The default value is going to be false. A text parameter for the endpoint, the URL, another text parameter for the body, a text parameter for the content type, which will typically be text/HTML, application/JSON. This is actually the default value that I want to give it because for the most part, in our case, most of the body of the requests are always going to be in JSON format, all right? I left here a placeholder for custom headers, which I don't really know exactly how is that going to work. And then a text parameter for the authorization, and which will be some kind of string with the API key, etc., and an integer value for the timeout with a default value of 10,000 milliseconds, all right? And I also added some, some descriptions, some etc. Now, one thing that I would like to do is that I would like to make sure that the authorization is optional. And because sometimes there might be APIs that don't require that. So in Grasshopper, the way we can do this is we can say, well, if this is parameters 0, 1, 2, 3, and 4, what I can do is I can say p manager slash in position 4, I want to make this optional. I want to make this parameter, this input parameter, optional. But I can do this in a little better way because at some point this, during development, it might change. It might not be the 0, 1, or 2. So the p manager, when you create a text parameter, it gives you as a return, it gives you an integer of which position this text parameter went into. So what I can do is I can say, give me that integer, you store it in this variable, and then I'm going to use this as the authorization ID. I'm going to use this as the position of the parameter that I want to make optional. All right. Beautiful. And then for the output, it's going to be super easy. What I want to do is I just want to offer the response. I just want to say whatever you give me back is going to be a text parameter. Give me that response as an item. All right. Fantastic. So what are we going to do now? I think we actually need to implement the actual HTTP request. Hi, D-Back. Hey, Songkran. Nice to meet you. I don't think we've seen you in the channel before. It's a pleasure. Make sure to join Discord and say hi and let us know about you. Okay. For solving the instance of this component, so for actually performing the request, I have already implemented the boilerplate of retrieving the information from the inputs of the component. So I've created variables for whether if the component is active, the URL, the body, the content type, all of that. I have gotten the data from the input parameters, and I have also added like returns in case we don't get the data, because that's data is mandatory. We can't really work without it, right? This is a very common Grasshopper pattern. If you don't remember this, make sure you check our advanced development in Grasshopper playlist. There should be a card popping up in the corner somewhere where we talk about all these topics, all right? And then typically something that you want to do before you actually start writing algorithms or doing anything is you want to make some validity checks to make sure that the data that you have is valid and it's good, right? So for example, something that I may want to do is I may want to check if the URL is valid. So, and actually the autocomplete is already telling me if the URL is, for example, if the URL if the URL is null, or for example the URL dot length, the length is 0, if I don't have anything, then I probably want to somehow return. But I want to do it in an elegant way, giving some feedback to the user. So I'm going to say add runtime message, and the message level is going to be error, for example. And I'm going to say empty URL. So I cannot, and I'm going to stop. I'm going to stop the execution of the component. Nothing is going to happen, all right? So this is typically something that we want to do. All right. So then the first thing that we need to do is we need to compose the HTTP request. We're not going to get into the details of how that works. It's kind of a lot, but basically what you want to do is you want to say, the first thing that you want to do is you want to turn the body of the request, which is in whichever format that is coming from Grasshopper. And you want to make sure that you turn it into zeros and ones that you can send across the network. So I'm going to create a variable called data, and that's going to be from the encoding library, which comes from C#. I'm going to take ASCII, and I guess encoding is not loaded here, so I'm going to add system text, and from the ASCII, I'm going to get the bytes for body. All right, so this is basically going to turn, and I can just make the explicit. This is going to turn body, which is a string, is going to turn it into an array of zeros and ones that is going to be sent through the network. Okay, I'm going to compose the request. We also saw this in the DALI video if you want to learn more. All right, then I'm going to create the request, which is going to be a web request that I'm going to create from this URL. And I'm going to make sure that this is casted to an HTTP web request. All right. And then this will be the type, will be an HTTP web request. All right. To this request, we're going to qualify the request. We're going to make sure that it has the exact properties that we want. So the request, for example, the method is going to be post because we want, because we want to send information with the request. The content type, which you already see, is going to be the content type that we're getting here. And maybe something that I want to do also is I want to make sure that we have some content type. So for example, and content type, and here for content type, which is probably never going to happen because I already have a default value here, but maybe someone just gives it an empty, I don't know. So if content type is null or if 0, then we throw an error. What is the next thing that I want to do? I want to, as you can see already, I want to set the length of the request to the length of the data that I parse from the body. And then, last but not least, I want to make sure that the timeout is equal to whichever value I am picking up from the parameters, right? And for this one, I don't even need to check if it's null or whatever, just because it's an integer. So the worst thing that can happen is going to be a default value of 0. All right. Now we need to handle authorization or not, because the request will be different whether if it needs to be authorized or not. So for example, if the authorization token, where are we? If the authorization token is different than null and the authorization token, the length is greater than 0, then we're going to have to create a request that has an authorization header and that has all the other authorization properties. So I'm actually going to copy some boilerplate that I have here, which is that we want to set the expect 100 continue flag to true. Very honestly, I don't really know what this means. And the security protocol is going to be TLS, which is a secure protocol, so that no one can sniff our authorization, our request, okay? Then another thing that we want to do is in the request, we want to set that authentication must be true. And we probably also want to set in the request, for the headers, we want to add a new header, which is going to be specifically authorization, if I type this correctly. And the authorization is going to be the auth token that is going to be provided by the user. So this is the input that we are getting from the parameters, okay? The authorization. So that is what we do if this request has an authorization. But if it doesn't, then we don't need to do any of this. So what we just need to do is we need to say the credentials are going to be just the default credentials. You saw credentials cache, default credentials. So whatever we get out of the box, we don't need to do anything special. Beautiful. Again, we're not going to get into what most of this means, but now that we get this, what we need to do is we need to actually launch that request. The way we launch that request is that we basically create what's called a stream. We open that stream, we launch the request, and we leave that stream open for data to come back from the response. All right. How are we doing that? We're going to be using the using keyword, which is basically a way of saying this thing that I'm going to define here, the stream, that is going to be a request.get request stream. I want this variable to make sure that it's properly disposed and garbage collected the moment I finish executing this block. It's just a way of being efficient about memory, making sure that requests don't stay open forever and they're not lingering in memory and they don't block any port, etc., etc., all those things. So we get the stream, and then what we do is with the stream, we rewrite that data. We write all that data, and we from the beginning to the end of the data. So we're basically sending upstream to the request, we're sending all the bytes that we captured, that we serialized with our get bytes. So the body was turned into bytes, and then we're sending all those bytes upstream to the server. All right. And once we have that, now we need to wait and listen for a response. So what I'm going to do is I'm going to create a response string, and then I'm going to try and listen to a response from the server. Okay. I want to use a try and catch because there are situations where this request might actually fail. It might be a timeout. It may hit a server that doesn't exist, an URL that is not valid. There's many reasons why this may not work out. So I'm going to use try catch so that my component doesn't crash Rhino or doesn't crash Grasshopper. So I'm going to say, I'm going to create a response, and that's going to be request.getResponse, get response from the server. All right. And then response string. So I'm going to turn this, which is right now a web response, I'm going to turn this into a string. So I'm going to say new stream reader. I'm going to take from the response. I'm going to take the response stream, and I'm going to read to the end. And then I may need to import stream reader. Yes, I'm going to read the entire thing and turn it into a string. Once I have that, excuse me. Actually, I don't know. I'm going to just response. Yes, no, wait. Yes, I'm going to just use the response here. I'm going to save directly to the response. All right. And if it doesn't work, then I need to figure out what happened here. So I need to say, I need to give the user a feedback about what happened. So add runtime document, runtime error, something went wrong, and then I'm going to use x.message. All right. So I'm going to print with also whatever is happening in the exception, whatever error message I get from the exception. And I probably want to stop executing the component as well. But if everything went well, now what I want is to output output. I want to output the response out through the component. All right. So what I'm going to do here is I'm going to say da.set data in the first position, and it's going to be data. All right. No, not data, response. Beautiful. So I'm going to save this. First of all, I'm going to build the solution and see if there's any error. It's building, so it means that everything went well. So it looks like from a code standpoint, there's nothing wrong here. So I guess I need to now see if this works. So I'm going to now execute the plugin. And as we saw in the previous video, I already connected this with Rhino. So the moment I open this, the moment I hit execute, it opens Rhino right away. I'm going to open Grasshopper. And I created in the folder, I created this test file called testing workbench, which is a folder that I'm using. And it has these two components that were ones that I prototyped in the, yes. So that's something that I prototyped in the, so now don't mind about this. So, and I can't, yeah. So Victor, hold on, give me a second. Victor, what was where did you have this option to remove dead components? Didn't you have this in your plugin in Clean Canvas? This one, right? There you go. Very good. Yes. What was the name of your plugin? And this is not part of the, yes. What was the name of your plugin? Melano something? Melanopod? Melano Plus. Yeah, so these are the two versions of the component that I was prototyping in the previous video that I still have them here, but because I deleted that code, it's not available anymore. Grasshopper doesn't give you a nice way of clicking and removing these ghost components, but thanks to Victor's plugin Melano Plus, I have this option to go here to display and clean canvas and remove all those ghost components. Good job, Victor. I love that. So what I'm going to do now is I'm going to go to my brain plugin. All right, not this one. So where is here? This one. And you can see that in utilities, I have HTTP post request. So I'm going to drop this here. And in post request, I have perform the request, set URL for the request, body of the request, content type, authorization, etc., etc. So let me plug a few things up here. So I'm going to say send, the URL is going to be, for example, the completions API. So the one that I was showing you here for OpenAI. So let's see if we can make like a raw request to OpenAI, right? I've created the body of the request. So I've written this JSON file that pings the DaVinci model. So that's GPT-3. Tell me a fairy tale is the prompt and the maximum tokens and the temperature. I'm using the same JSON structure as the body of the request that is specified here in the documentation, right? And then, so I'm going to plug that into the body. The type, you can see that by default it has application JSON. So I'm going to keep that. I like that. The authorization needs to be some kind of text that is, in this case, is going to be bearer, the word bearer, a white space, and then the OpenAI key that I'm getting from an environment variable that I have in my system. And if you don't know what this means, we have a video about how to get your OpenAI key and how to read it from an environment variable in your system. We will probably turn this into a component in our library as well. So get environment variable, right? And so I'm concatenating both, and I have now the bearer token and this API, the bearer token and the bearer word and my API token. So I'm going to plug this here into authorization, and the timeout is going to be 5 seconds. All right. So right now, this is not doing anything. All right. So I don't get anything because it's deactivated, but I'm going to turn this on. All right. And you can see that right now I'm frozen. I can't do anything. Oh, and I got something went wrong. The operations has timed out. So it looks like 5 seconds is not enough. So I'm going to crank this up to 10 seconds and I'm going to try again. So I'm going to try again and you can see that it's frozen. I can't do anything right now. And what? The operation has timed out? Really? So let me turn this back off. This is very strange. This should be more than enough. So I'm going to allow 25 seconds. All right. So I'm going to do 20 seconds. I'm going to try this on again. And I'm waiting. I'm waiting. Grasshopper is frozen. And yes, I did get the response. That is strange. It took more than 10 seconds. Okay, I don't know, right? But you can see that I get in return, I get a JSON object with all this information. So I'm going to use the JSON plugin to deserialize the response and then get just the prompt. Once upon a time, there was a beautiful princess who lived in a castle with her family. Tell me a fairy tale. It looks like this works, all right? So what have we done? We have made a custom, let's call it like a hand brew, like a craft request to the OpenAI post, to the OpenAI API, to the completions API. So now we can ask ChatGPT for a bunch of text, correct? And because we're doing it raw, because we're customizing all the parameters, we get a response that has the entire JSON response And then we need to manually deserialize this using some library, using JSON, JSON, etc., etc. So this works so far. It looks like it works. So we're going to give this a thumbs up for right now. So we have a component that can do post requests. All right. Now there's two things that I would like to improve here. The first one is that, as you have seen, post requests actually do take quite some time to execute. It's not nice. In this case, it took 11 seconds. And you can imagine that if we actually create a complicated Grasshopper definition where the output of certain components becomes the input of other requests, etc., and we daisy chain a bunch of these, this may actually take several seconds, if not minutes, to execute. And having Grasshopper frozen as this happens is probably not a nice thing. So the first thing that I would like to do is I would like to test a version of this component that, instead of doing the request synchronously, which is this idea that the entire execution flow is halted while the request resolves, what I would like to do is I would like to implement an asynchronous version that keeps Grasshopper alive and responsive while the response resolves. And when the response resolves, this updates and triggers an update chain all the way down. Okay, so that is one thing. And the other thing that we will eventually want to do is that, because this particular API is so popular, what I would like to want to do is to create specific Grasshopper components that are specifically designed for the completion API of OpenAI, the chat API of OpenAI, the image generation API of OpenAI, and just make life a little easier for people. Under the hood, it's going to be still post requests. It's just that a lot of the information and the body and the parsing of the information, we will do it under the hood in the components so that people's life is a little easier and the information is offered to the user right away. Okay, so those are the two things that we will do eventually farther down in this playlist. And I think that the very first one is going to be writing a version of this component that, instead of being synchronous and halting the execution of Grasshopper, is going to be asynchronous. And it's going to let me keep interacting with Grasshopper, and it's going to trigger an update whenever the response is returned. All right, so let's take a look at what that could look like in the next video. All right, thank you very much. If you liked this, make sure you hit the subscribe button, like this video, etc., etc. All those things. See you on the next video. Bye bye. Okay. And now I'm going to record the introduction. All right. Hello, this is Jose Luis here at Parametric Camp, and welcome to another video in this playlist that I still don't know the name for: building the brain, a plugin for Grasshopper machine learning. You probably already have seen the title of the playlist anyway. So what I would like to do in this video is write our first component for the plugin, and arguably the most fundamental one, the more core one, which is going to be building a custom HTTP post request, or the idea that for most of the APIs that I know of out there in the world, the way you interact with them is using an API, using a post request, which is a request where you go to a particular URL, like for example here, the OpenAI one, you give it some information. This is called the body of the request. That is what you actually post with your request, and some optional authorization information and maybe like a timeout. And then if you perform the request, then that information gets sent to the server. And then when it comes back in the form of typically a JSON file or some other text file that we can deserialize, for example, in this case using JSON, and then get this kind of, for example, in this case, a text completion, or for a fairy tale, like a princess in a beautiful princess, etc., etc. All right. This will be interesting because if at some point in the plugin we don't have an API for a particular, we don't have a component for a particular API, people will be able to create their custom requests in a manual way. All right. So let's take a look at how would we implement this. All right. Less tokens. Yes, you're right. Made it much faster. Okay. All right. I want to go drink some water, and then we're going to take a look at the asynchronous version of this component. We're going to take a look at Victor's code and figure out how to frame what we're doing here. Okay. Let me come back to that in a second. All right. And I'm going to now take this, I'm going to close Grasshopper, I'm going to push changes. All right, git status, git add, git status, all right, git commit, sync post request, git push, okay. All right. Now let's take a look at Victor's implementation. HTTP component, async callback. So we have post async, create an async generic HTTP request using the callback. We have state, idle, waiting, done, error, response. We have the input parameters, we have the response. This is a method that actually does the work. So requesting, if state is waiting, and then the default is this one, which does the request. It it does this message.requesting. It creates a callback, and then it posts using the callback. And then the request is going to be task run try get, and then whenever the callback new expire solution delegate expire solution. And then this is a callback that arguments, the method and the arguments to which is recompute. New expire solution delegate. And the icon and the UID. All right, let's give this a try. No? All right, so testing workbench. Oh, it was active. I saved it as active. Okay, false. And then brain and utilities async. So it's going to be this guy, this guy, this guy, this guy. The authorization, no. The content type, no. The authorization here. And the timeout. And the message, and I can requesting, and I can move around. Yes. And done. Okay. Very good. And then it doesn't get anything. Beautiful. Okay, this works great. Victor, we're doing this. I like it. I like it a lot. Which I wonder. Delegate. Delegate. New expire solution delegate. Is this, is this executing? Is this really not executing? I want to try something. So I'm thinking whether if this is actually under the hood executing. So recorder, data recorder. We're going to use actually this one, which is nicer, data. We're going to use data recorder. Are we recording? Okay, and then we're going to, because I wonder if when it's off. Yeah, I guess when it's off, it's creating an empty string. That's not an issue. That's probably how it should be. But then, yeah. So here it created 3 empty strings. Huh. So if I turn this on, when turning on, it creates a null output. And then when turning it off, it creates another empty string. And null. Yeah, so we are triggering updates. You see the problem? So we switch off and we get an empty string. This is what I expected. But I would expect that as I turn this on, when I turn this on, it should not. Yes, because I'm basically creating a response as I turn it on, and then I'm triggering another. I would like this to not generate a response. You see the problem? Let's see if, yeah, let's see if we can actually, if the speckle approach actually, are you there, Victor? You see the issue? Let's see if the speckle version of this does the same. Utility components and asynchronous here. Yeah. Okay. I know, I know. So I actually, did I ever share my dynamic data library? There is a way to do that. It's just that it's a very dirty process. So if we do then this, and we do, which one is this one? This is a speckle as asynchronous, and this is callback. Okay. Okay. All right, so I'm going to drop this here. I'm going to press false. You are body, the bearer token, and the timeout. And I get all these. So I'm going to turn on null requesting and the result. And if I turn off, empty. And if I turn on, this is with the speckle, right? No, this is callback. Ah, damn it. This is speckle. Yes. So let's try this again. URL, body, authorization, timeout. All right. So now I turn this on, and you see it doesn't produce an output until we get the response, and then we do false and empty, and this is fine. But as I turn it on, it doesn't create an output because it doesn't expire the solution. Because there is a way to do that where it doesn't expire the solution. And the way to do that is, maybe we can actually do that. Because the moment you return, the solution gets. So let me see if we can actually dynamic, where do I have this? Dynamic data tools in Grasshopper. I did have a bad version of this somewhere. Where, for example, switches. Gate component. So maybe, so DA, for example, disable gap logic. This is not the risk. This is not the. This is not a solution, but this prevents null values to be being assigned. So here, this is callback, turn on, requesting. Oh, was it that simple? Really? Empty. And then turn on, dead. Oh. And we don't get. Okay. Is that what Speckle is doing? Asynchronous Speckle, worker instance. No, the worker has nothing to do with this. So, numerical progress. Worker instance, display progress, timer, done, increment workers, progress repose, display progress, yeah, blah, on display expired. Action delegate on display expired. Before solve instance, killing, cancel, interlock. After solve instance, debug, write line. Expire downstream objects, yes. Prevents the flash of null data until the new solution is ready. If set data equals 1, base, expire downstream objects. Request cancellation, interlock on display expired. Raises the display expire event on the top level. And set data. Expired downstream objects prevents the flash. So let's see. Let's try something here. So, nope. So here, expire downstream if state waiting, done, error, state idle. And where is the state here? What are we setting the state? Waiting. And where is this set to waiting? Callback, state done, state error. Where are we setting this message requesting? So this never triggers actually. So this should be more like state. So what is this? So I guess state equals state dot waiting. And I think I'm going to if state dot if yeah, this is confusing. Sorry. I'm going to rename this as current state, and then this is going to be uppercase state. Request state, and then this is going to be waiting, and then this is going to be idle, and I don't think that idle is being used anywhere, as far as I can tell. So we should probably, now if current state equals state dot waiting request state, then expire downstream objects. Okay, so this is empty. We press true, requesting, and then we're done, and it doesn't expire on waiting. I think it's expire on done. Yeah, well, it's definitely not triggering anything. Down. I think it's a toggle. No, I actually think, Victor, that this is actually a very confusing. Expire all objects that depend on any of the outputs. So actually, request cancellation on display expired. True. I think this is the one where we want to, and then callback is going to be Rhino invoke on UI thread expire solution delegate expire solution equals true. And we need to schedule a solution. How did I do this back in the times? I forget. So we have this report progress, worker instance, task creation outputs, display progress, start increment exchange, set data, Rhino, invoke, expire solution, delegate expire solution, true. Which is kind of what we could do here. We could just say action callback equals and this is called invoke solution action. And then Rhino up. Rhino up, invoke yep. Action, delegate, expire the solution. We turn the delegate into, okay. Which basically means that we call the callback, which expires the solution when this is done. Otherwise, display progress. On display expire races. Display progress on display expired, and the only thing that this does is that it resets the message. Expire downstream. Expire objects depend on any of the output parameters. And I guess, yeah, we're running this and then current state request done, request and okay, I think this should work. Why? So it's not working. Let's see. Because we haven't really changed anything here. Are we going down a rabbit hole? Is that what we're doing here? Sounds to me like we are. Okay, so we got, this is a speckle, this is a speckle one, this is, okay, so if I turn this on, it doesn't expire anything, it's requesting, and then when it's done, it doesn't trigger. It doesn't trigger any updates, and false, it doesn't trigger any updates either. Disable gap logic. Because I don't think it's really, you want to disable the gap logic for the current iteration. Index of output parameter to disable. I just don't think this is really, I think this is still triggering an update. It's just triggering a bad update. it's triggering an update. It's like an error update, if you will. Whereas this solution, it's a bit cleaner because it doesn't trigger any update. It doesn't trigger a good or a bad update. This one will trigger like an empty update, and it will make everything after that create errors. And if you're writing to a file, it will write empty stuff to the file or invalid stuff to the file. I think we can do better. There's got to be something that we're missing here. Return, killing, cancellation, task, interlock, exchange, state, before solve, after solve instance. Expire down, prevents the flash of data. Expire downstreams if set data equals true. We don't want to expire. Solve instance, base worker, duplicate, get data, current circuit, worker, cancellation, tasks, add, set data equal, worker counts, on display expired, and this is just for the request cancellation, blah blah blah, on display expired, cancelled. Let me try something. Add runtime message, level, remark, comma, requesting. Actually, so this would be done, and this would be error, and this may actually not work because we don't have the and now it's creating the null, and we don't have the update. Yeah, you can add a message on a non-thread, you're right, unless you expire the UI, which is what they're doing here on the yes. So you could do this theoretically. Post request, yes. So you could do this. I think, and you could do that, and I think we're going down the rabbit hole. So we get a null because I deactivated we get requesting, and then, oh, cross-thread operation not valid. Ha ha ha, you're right, because we are in a different thread. Canvas, okay. All right, can't do this, can't do that. And then the callback is basically expiring the solution. But how is the solution not expired? Current state, callback, current. What about both things together? Request state idle. Waiting. Requesting. If request state is done, request state is idle, is error, error. I don't get this. You see, I get this is not what I want. And done, but I don't get the output. Oh. Huh? What? False. It doesn't trigger an update. And then so it does return. It's just that it doesn't trigger an update on. I think the option should be expire on done or idle, not waiting, since there's no data on waiting. Okay. It's just, you might be right. You might be right. But it's just that my understanding was that for some reason the language is just weird and it works the other way around. But maybe I'm wrong. Hmm. Okay. Okay. Yeah, whatever. Huh. True, false, empty. And then I turn this on and I got this. But then I get the result and then I get empty. Well, I think you were right, Victor. I think I was just being stubborn about some previous bad experience or something. I don't know. So that then if I remove the gap logic, then we're not going to get the orange, which maybe is not that terrible either. Okay. And then, all right, so it's empty right now. So now we turn it on. Null, damn it. Done. Empty. True. So it's literally just the gap logic that is working right now. Ah, so this is basically doing absolutely nothing? So it's not really doing anything. All right, hot reloading. Okay, so turning false, null, false. True, hot reloading, null, false, no. Do I? You might be right. Okay, so post async with the callback. Post async, not speckle. No, wait, not. Callback. Okay, U B type authentication timeout. Screw the timeout. Null. Okay. Damn. Now I kind of want to get it right. This is not cool. Victor, what have you done? What have you done, Victor? Now I'm not. Now I'm stuck on this. Base worker task, numerical, report, done. Exchange, set data. Informs the document that owns this object the solution has expired. The current object was set to blank as a result. This method is recorded as expired. Any other object will depend on this object until it considers in clear data. On expired solution, on display expired. So this is just for the progress to show the message before solve instance. Return killing. Interlog exchange. This is boring. If set data is zero, if set data is 0, if worker count, if state is different than cancellation, blah, 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 exchange on the display expired. Request cancellation on display expired. What do we do now? What do we do now? And what is set data here? So we only basically expire the objects when. So I guess we only want to expire if they're different than waiting. Post, action callback, post, try, and then the callback. And then the callback is just expiring the solution. I think interlock exchange is some way of making sure that in an asynchronous environment, you're not overriding. No. Ugh. I know. Does the return after post cause an expire? I don't know. So this is empty. We turn this on. We get a null. Empty. So, and if I do equals, then blocks the thing, but upon completion, it doesn't stream down. And it doesn't come back. else expire solution. Reload. Up. The application is in break mode. What happened? Stack Overflow. Oh my god. Oh boy. Stack Overflow. All right. Okay, what if I do this? I guess yes. I guess because it's like expiring and yeah. Yeah, I guess this is basically making it call itself over and over again. And mhm. This is weird. Prevents the flash of not until the new solution is ready. Base if hmm. I really don't know. I'm stuck. Hmm. Yeah, because we're basically doing the same thing. Like I don't see any difference here. Cancellation sources, add, set data. We are calling the and here and done is a function that takes everything and if it works then it just expires the solution. Display progress before instance, after solve instance. And done if state and set data is 0, exchange interlocked, exchange set data equals 1, workers expire solution, and then this is expired downstream objects. which probably sets the flag to 0 as well. So this is basically a gate. Okay. And then after that, the expired solution is this ever set to 0? It is set to 1, it is expired, and then display progress before solve instance, which basically this means when is this set to 0? Interlock exchange set data to 0. So solve instance basically. I see. Okay. All right, so let's do the following. What if we create a variable here which is should expire, should update outputs, and this is going to be false, okay? So, and then what we do is every time we solve an instance, we say should update outputs equals false, okay? And then this is the solution that we inspired, interlocked exchange, and that is a thread save, set data, request cancellation. Yes, and then what we do here is that this is a callback that takes a callback that sets output should output equals true. And if should output outputs, then we expire the solution. So what this will do is that anytime solve instance is called, this is set to false. I don't know that that is a good thing. So this is when we create the component. And this is set to 0. This is set to 0 whenever we call solve instance. Message done, solve instance. We set this data to 0, message is done, solve instance, get the task, current run, cancellations, expire downstream. So maybe instead of that, this should go here under post. I'm doubtful about that. Then false and empty, null. Quang quang. Nope. Empty, turn on. Done. False. So what do I got here? I got empty, just because there's nothing. True. Done. And has an expire. And if this is false, yeah, it's not triggering an update, but it is outputting an empty. Okay. If active is false, if active, this message response should out. Yes, because we want an update here. We want to gate that. So we just got an empty, turn and true, did get null, and now false, and I don't get, but I turned true and it, how did it happen? It's exactly not, it's the other way around exactly. Oh boy, how did this happen? Because I should set that up before setting the data, which is what triggers the expired downstream. Ooh, is that possible? Okay, turn it on. I hate you. Oh boy. Done, and I turn false, and I don't get the empty string. I'm just going to do 8 tokens because it's gonna take forever. It's taking forever. Empty. Did I get empty? Oh, I got empty because I changed this? What? Wait, so 10, if I change this to 10, I get another empty because it's false, but I am getting an update. So if I do true, what happens when I do true? When I do true, I go all the way here. This message current state. Ah, I feel like I'm so close. If it's not active, this message should be no request. Say data response, no request. Okay, and I should be getting a null now, an empty. And no request. But I should be getting set data response and nothing. No response. Set data. This is going to be awful. Okay, so let me do this. I'm going to clear this. True, a null. I get this. I don't get the empty string, but I am getting the no response, but it doesn't. I get the null. Disable no response. I'm not getting that one. Okay, so here's the expire solution true. Yeah, definitely a break could help. Maybe like a week of a break. feel like I'm so close. Damn it. I feel like except for this, everything else is pretty much. Yeah. So no response. Yes. Disabled. No response. Yeah. Okay, what if I did, this is crazy. What about this? Post, callback, let, void, output, hack. And then string is going to be result. And then action callback. And then what I'm going to do is the dirtiest thing in the world, which is going to be just mimicking. So this is going to be, this is an awful hack. I'm hating everything, my life right now. But so response equals result, current state equals request done, and then callback. And then here, I'm going to change this to this message. This message disabled. Then this same thing, and then output hack, no response, and then callback hack. Oh, this is awful. I'm already, no response, true, and then I get a message, and then done, no response, and done. Oh, I guess, yeah, I guess current state. Current state done. Output hack. It should be hack, and it should be idle. Yes. So done. What? Infinite loop. Yeah. Infinite loop. Okay. Current state idle, callback, expire solution, and when we expire solution, we basically trigger another solution. Oh boy. I need a break. I'll be right back. Yeah, I mean, now it's more of a matter of stubbornness. But I mean, this could just, I don't know why. I mean, we could just be using, uh, speckle. I don't know. Okay, I'm gonna have to go because I actually have another call that I wanted to attend to. But yeah, we're gonna figure this out offline, and then we will get back to you next week. Okay? Thank you very much, everyone. Sorry for that. Bye.